The first buildings constructed of straw bales appeared on the plains of Nebraska in the late 1800s. With no timber or stone readily available, the settlers made use of baled-up straw stalks, a product of the recently invented baling machine. More than 100 years later, straw bale houses remain relatively rare, although an increased awareness in sustainable building has boosted their popularity. In this programme, we look at the basic construction of two-storey straw bale houses in Waddington, Lincolnshire. Built in what is known as the Nebraska or load-bearing style, the bales themselves take the weight of the roof. There is no structural framework.
My name's Paul Spittlehouse, I'm the site manager. We're building two three-bedroom semi-detached houses on a small estate in Lincolnshire with straw.
Generally, all bales are about the same. They're all in feet and inches because they're made in imperial size baling machines, and they're generally 18 inches wide and 14 inches high, and the length can vary, but we try to get them about 1 metre long, just over 1 metre.
Handling wise, the bales they're under the 25 kilograms, which a bag of cement is for manual handling. You will need long sleeve shirts really to handle it. It is a little bit spiky. It's easy to lay, quite quick to put down. It's quite labour intensive. The timberwork side, the base plates, wind posts, door head details, window head and window sills. There's a lot of detail in the timberwork.
It's very important that you keep your straw dry at all times. So it needs to be dry when it comes off the field, it needs to be dry when it's stored by the farmer, it needs to be dry as it's transported to site. You need to keep it under cover when it is at site, and when you're building you need to keep it dry as well. The top and the bottom of the bale must be protected from moisture, always. So how we're doing that with a load-bearing structure, which doesn't have a frame at all, is that we actually construct the floor and the roof first, and we put those onto the site on temporary props, and they become our roof covering. And then from there we drape tarpaulins down from the eaves and we sheet in the sides of the scaffolding, and that then gives us a completely dry working area where we can store the straw inside and we can work on the walls whatever the weather. It works really, really well.
Initial site set up, as you can see around the site, we have an 8-foot high solid plywood hoarding. I suppose it varies on locations. We're fortunate here, it's a nice little estate. There's been no damage or anything. I think fire is a risk. Compressive wise, straw isn't a risk, it just smoulders if it's got on fire. But it's if you've got quantities of loose hay or straw about, there is a chance that people can throw matches into it. So it's keeping the skips separated, any of the straw isolated away from the building where you're not using it, covered over. We've built the floor basically at ground level, then we raised the floor up above the height we needed, which formed a temporary roof for the bale builders to work underneath. On the bale completion, we bring the crane back to lift the floor, pull the temporary scaffolding out of the way, and lower the floor onto the bales. The floor is guided by slots underneath which correspond with the wind posts, and once the floor is laid in place, each floor for the semi-detached houses weighs approximately 3 tonnes. This gives it the start of its compressive strength. It's settled down about 45 mil from the original size of the bales, compressed down, and then we point loaded the corners with ton bags of sand while we have the crane here to achieve a level floor before fixing any of the wind posts into the floor plate.
We compress all our buildings. Most of our buildings have no framework whatsoever, and it's really important that you get all the extra airy bits out of the straw. The straw is a very strong structural block, and when you put it under pressure, under the weight of the floors and the roof, it becomes incredibly strong so that you can't move it at all. And what the compression does is it makes the walls unflexible. So you start with a very flexible building block, You build it up, put weight on it, and it becomes very solid, and that way you can put plaster straight onto it and the plaster won't crack.
The foundation detail for this building, typical strip footing, the dig's the same as you would dig a normal house footing. Then it varies then straight away. The base of the foundation is taken up with 20mm clean gravel, which is vibrated, and this settles down. Then we have a 450 limecrete footing. The limecrete does absorb carbon dioxide, it's natural, it's more friendly to the environment in regards to using cement as the alternative. The limecrete we had to mix it by hand because Castle could only deliver 5 weeks down the line, so we had to mix everything by hand. That was quite time consuming, but having a bit more lead-in time with the project, we'd have had it delivered, and it shouldn't have been any different to using concrete.
When we get the bales from the farmer, sometimes they don't have really flat ends, and because this is a very thermally efficient house, we need to make sure that when the bales go together, the high points don't make an insulation gap between the bales. So before we put them in the walls, we flatten off the ends so that the top of the bale is as flat as we can get, so that when the two come together, we get the maximum surface area touching. We call that trimming the bales, so that we get them so that there's no possibility of air gaps coming through the joints. And the other thing we do once they're in the wall is that we stuff any little gaps that there are with extra straw, so that we're really certain that we've got a super insulated wall. You pierce your first bales onto those spikes, 2 for every bale, and that stops any lateral movement of the bale, and it starts helping with wind forces as you build the wall up, with putting a series of hazel pins through the straw. And that first course has to be laid very slowly and carefully because it's the template for the rest of the building. They're laid on the ladder, they're notched around any fixing points that you have for your windows and doors, and they're carefully placed at corners so that you have a really nice tight fit and all the corners are vertical. When we've built the walls up with 4 bales, then we put long stakes through that are 4 bales length, and we generally use hazel. Sometimes we use sawn timber if we can't source enough hazel, and we spike them at one end and we hammer them all the way down through the bale so that they overlap with the one that's in the base plate. And we do that on the 4th course and on the 6th course and through the wall plate on top as well. So we end up with a series of overlapping pins throughout the whole wall, so the straw then doesn't act as individual bales, they're all linked together, and it gives the wall greater integrity. It's not necessary on all buildings, but particularly where you've got quite severe wind loads, it helps to prevent the force of the wind.
The door and windows are dictated by the wind posts, which are put in as the bale build goes up. These wind posts give us our structural fixings for door frames. A 200 by 32mm lining goes around the openings attached to the wind post, and then the door frame fits to the inside of that. This 32mm gives them a render point to render around to, and then we seal the doors up with linseed oil putty, slate drips, all natural products. So there's quite a lot of detailing in the windows and doors, i.e. drips and that, to keep the water away from the lime render.
We've got various places on the wall where we have fixing points for the windows and doors. They're not structural posts, they don't take any weight, but they're places where we can fix the windows, and we want the straw to notch around those posts so that there's no possibility of air that can get in at that point. And we do that by using a template and cutting down into the edge of the straw with a saw and just taking out the excess, and then it fits nicely mouthed around those posts. There's a lot of places in the wall where we have to customise the bales, so we have to make them into half bales or slightly less than the length that they are, And you do that using long needles that you've seen people using. You thread them with 2 strings because the bales have got 2 strings on them. We want to make them into 2 halves. And you thread through the bale, around either side, and tie them off with a trucker's knot. And you do that on both sections of the bale. And then once you've tied your knots really tight, you take off the original strings, and all being well, you haven't twisted your strings together, and they come apart nicely into 2 separate bales. Don't generate a lot of waste on these building sites. We do create a lot of loose straw, which we take away in those big ton dumpy bags. And we try on each site to find livery stables or a gardening company that wants the straw either for bedding for the horses or for mulch for the trees. There's a big debate at the moment about whether we need the render in order to make these buildings strong. We've built enough of them now that we're absolutely certain that these buildings are strong without the render. The render is an aesthetic finish and a weatherproofing finish. And there's no doubt that it does also add strength to the walls, but the walls don't need that extra strength. They're perfectly strong without it.
Even though Amazon Nails confirm that these domestic houses are structurally sound without render, and that render is primarily applied for its weatherproofing and aesthetic properties, research has shown there is a significant structural benefit to be gained by applying render. In tests at the BRE's Centre for Innovative Construction Materials at the University of Bath, a lime-rendered wall suffered no significant vertical displacement until 10 kilonewtons of load was applied. That's over 2 metric tons per square metre. In contrast, a similar non-rendered wall had compressed and buckled around 90 millimetres under the same vertical load. Centre Director Pete Walker says tests have shown that renders give straw bale walls significantly, up to 4 times, greater load-bearing capacity, and also reduces vertical movement in the walls by up to 50 times. In short, he says there are significant structural benefits through rendering straw walls. Now, let's see how that render should be applied.
First of all, you prepare all the straw ready for plastering. So if you've got any big holes where you've got joins between bales, you stuff those full of a lime straw mix first to even them out. Then you put a key coat on, which is just a very thin coat of lime and sand, lime rich, that covers the whole straw, but you're not hiding the straw at this point, you still see it sticking through. Once that's gone off, which takes about 24 or 48 hours, then you put your base coat on, which would be about 25mm thick. And that goes on, and that really is where you get the look of the thing. So you're flattening it out, you're making it straight, you're rounding the corners off. Once that's gone off, which will take 4 or 5 days, then you can put your top coat on, which is just a thin 3mm coat of finish that covers the whole thing and gives it a really pleasing look. On top of that, then we'd use either a lime wash or a mineral-based paint to finish it. With the straw, it doesn't matter when you're working. It's the lime render that is time-specific, because the lime must be on the walls before the temperature drops. It mustn't get frosted. So we wouldn't consider doing lime work outside the months of, say, we'd work between April and the end of September with lime. And after that, we'd do all the internal work and then carry on with the lime in the spring.
On the face of it, straw bale construction seems a cheap alternative to traditional build. Let's take a look at a typical 3-bedroom house. And let's say that the house has walls with a surface area of 144 metres squared. Using traditional brick and block construction, it should require around 1,500 blocks and 76,000 bricks. At a cost of around £10 per square metre for the blocks and £40 per square metre for the bricks, that comes to a notional cost of around £7,200. Bear in mind, this is simply about materials and delivery cost. If we use straw bales for the same 3-bed house, we would need around 375 bales, each costing around £2.50, giving a grand total of £937. So, theoretically, using straw bales for a standard 3-bed house would save more than £6,000. But, as we shall see, the reality is very different.
Should cost be a driving factor? It is a driving factor, we can't get away from it. At the moment, we're able to build straw houses that are about comparable in price as building a timber frame house. Now, that's going to come down an awful lot once they start becoming mainstream. So the first houses of anything new are always more expensive. But even being more expensive than they will be in the future, they're still at a comparable price. The council here are building these houses partly because they're environmental, but because they're going to save them money. And you save money in the build cost, but you save money in the long term in the running costs, because they're designed to maximise the heat that you get from the sun, and they're so well insulated. There's hardly any need for heat in these houses.
The reason we're here on this site is that North Castile District Council has a priority to provide affordable housing to the district. We're able to do that through planning policy, but also we wanted to take a direct route, so we decided to build some straw houses. Building with straw is a viable alternative to traditional construction because of the added value of the insulation costs. In terms of actual pounds per pounds, it's probably no cheaper to build with straw than it is traditionally. But I think the added value of the insulation and the running costs to the end user really outweigh that cost. And if you wanted to build traditionally to the same levels of insulation, it would cost an awful lot more. So I think, in terms of is it viable, it is if you're aiming for a high-end product. If you want cheap, cheerful housing, traditional is probably the cheaper option. These will be the first houses built of straw in the district, and certainly we've not built any new council housing for 20 years, so these are unique to us. Long-term maintenance shouldn't be a problem. Amazon Nail's clearly the experts in the field, and they're telling us that as long as you keep them watertight and keep the lime render repaired well, then they should last indefinitely.
If you're building a bathroom or a shower room into your straw house, which of course you will be because it's a normal house, then you would try to make sure that the walls that took the bulk of the water were not straw walls, were internal walls. And you would keep your tiling to a minimum. So any wall that has direct water has to be tiled, whether that's straw or another wall. And we would cover that section with marine plywood, something that will resist water ingress, but we'll keep that to a minimum because we want the straw to be breathable, and we also want the room to deal with condensation, and lime and clay renders both do that very well. So we would maximise the areas that had lime or clay on them inside those rooms and keep the tiling to places where the shower actually hit the walls. People do get a bit concerned about rats and mice in straw houses, but really it's not a problem whatsoever. All houses, whatever they're built of, occasionally have mice in winter, and you get mice in straw houses for the same reasons, but you don't get more mice or more rats. Rats and mice like to live in cavities, so they're much more likely to live in the cavities between your stud walls, in your internal walls, in your floors, in your ceilings, than they are in that monolithic straw wall that's plastered. There's not really any food in that wall for them. It's straw, it's not hay, and that's a very big difference. When I first learnt straw bale building in the States 15 years ago, they taught me to use metal rebar to pin the bales together with, and I very quickly changed that because the metal in the straw is a really dodgy issue. If you've got warm, moisture-laden air passing through the bale safely to the outside of the building, if it hits a cold piece of metal, it's possible that moisture could condense and you could create a damp problem inside the bale just where you don't need it. So we have a policy of not using any metal whatsoever within the straw for that reason.
Straw building is a system we intend to use in the future. We already have planning permission on a second site, and the workforce from this site will be moving on to the site in March of next year. So the other intention of the council really is to promote the system building across the district as well. So if other architects or developers wish to develop their own straw building, the expertise will not only be with the district council but also with local contractors as well.
I've found working with straw quite enjoyable. For a builder like myself who works with concrete, steel, regular building materials, to use something unorthodox, slightly different, with all the limecrete, all the natural building products like sheep's wool insulation, pavatherm board and the straw. It's been quite enjoyable. It certainly gets you thinking and tests the grey matter.
There's a very wide variety of people who choose to build with straw, and they all have different reasons. Some people choose it because they absolutely want to care for the environment and they want to build a natural house. Some people choose it because they're concerned about their health and they don't want to live in a house that has any toxic materials in it. Some people choose it because it's very easy to build as a self-builder. Although it takes time, you can save an awful lot of money in building your own house using straw. Some people choose it because it can reduce your running costs in the long term because it's so thermally efficient. And people will choose it because it's cheaper. It's just about on a par with other house building methods at the moment in terms of cost. It will definitely be cheaper as the years go by.